Hi, my name is Zuzana and I'm one of the founders here at Malai Biomaterials. Today I'd like to welcome you in our first episode of podcast. The work in progress name is the Green Mythbusters. But as I'm saying, it's just work in progress. It does sound a little cheesy, so I'm sure we'll find a better name for it. But for now, let's just call it that. Why am I talking to you today? I'm, of course, as I said, one of the founders here, but moreover, I've been a material designer and researcher for the past 10 years. Material design is actually the reason why Malai Biomaterials exists, and it's been my passion for a long time. Transforming different kinds of ingredients into matter, studying the processes, compounds, applications, different kinds of manufacturing systems is what I do as part of my research. And I have worked with experts from different kinds of fields, such as chemists, material scientists, designers, mechanical engineers, microbiologists, etc., to assimilate the necessary expertise for my practice. I started off as a textile and fashion designer back in time. However, quickly I realized that while I love doing the design work, I've been also quite disappointed by the way things work in the industry because unfortunately our manufacturing systems are not really built on circular or circularity principles. They are very linear systems, which leads to dependence on petroleum-derived products, creation of waste, environmental pollution, and moreover, manufacturing systems these days are really complex, and it's quite difficult to navigate them and to find transparency when it comes to sourcing materials. So today, I'll be talking to you about a field which is quite close to our hearts here at Malai Biomaterials. I'll be talking to you about alternatives to leather. What's the objective of this podcast? Objective is not to shame any of the materials existing out there. The objective of this series is to tell you a little bit more about materials. What are they made of? What are the complexities surrounding their manufacturing systems? We'll talk about the challenges of being a practitioner in the emerging field of circular economy, etc. It's not always going to be just me talking to you in the podcast. Actually, only this episode contains purely me. Otherwise, you'll be seeing me talking to different guests. There will be different kinds of experts from design-related fields, from any part of circular economy that you can imagine. We will have informal conversations together, talking about what it means to actually run or to do what we do in practice, what are the challenges, and to give you a little bit of an insight. Of course, the choice is up to you. We live in a world where the word sustainability and circular economy is being used a lot more, and very often, unfortunately, it is used by the industry to sell some kind of products. It's part of the greenwashing and green marketing, and it's, I think, becoming increasingly important to stay very well informed when it comes to choice of materials, especially if you have a brand, if you are a designer or manufacturer, and you want to do the right choice for your product. So today we'll be talking about alternatives to leather. There are many alternatives to leather out there existing these days, and not all of them are very well understood. Most of them are just sold as vegan alternatives to leather without necessarily disclosing what are they actually made of, and what are their advantages in terms of material, different kinds of material properties. So let's talk about the inspiration for all this, which is the animal leather, the original thing. Animal leather is a fantastic material that has been with us, humanity, for thousands of years. It probably was one of the first materials that we started processing for our benefit. And it is a natural material that's designed incredibly well. It is designed to be able to effectively transform loads and fulfill metabolic functions of an animal. And of course, as when we process this material, we want to retain these wonderful properties that animal leather has for our benefits. So as we said, animal leather is bio-based because it comes from a living organism, and it in its raw form is also biodegradable. It's made of protein fibers. Protein fibers, in this case, are collagen and elastin. And as such, they need to be preserved and cross-linked, which is something that we do by means of using tanning process. Tanning process can be done in different ways. We can tan leather using chrome tanning or vegetable leather tanning, and sometimes we can use a combination of both. There are advantages to, different styles or different ways of tanning. And leather usually comes in quite a bit of a thickness, and there are different grades of leather out there, defined by which layer of the skin the leather actually comes from. So we know that the uppermost layer of animal skin, where the epidermis is called top grain, because you can see the beautiful grain, natural grain of leather, and that's the most expensive and valued leather out there. Then we have the split leathers. If we leave the fiber structure kind of open and visible, and buff it a little bit, then we can have the suede leather. If we cover it with a polymer coating to resemble top grain, then we can be talking about genuine leather. And then we also have different kinds of leather depending on the type of animal. So chrome tanning was invented at the end of 19th century in order to provide a leather tanning process that is quicker and cheaper, because vegetable tanning is done using natural compounds, tannins that are there in different plant matter, in barks, in wood, and etc. And they do the work beautifully, but they do it slowly, so it can take up to 15 months to complete the vegetable leather tanning process, as opposed to chrome tanning, which can be completed in less than a day. As I said, it's also usually cheaper than vegetable leather tanning. In terms of material quality, chrome tanning usually gives us leathers that are much softer and flexible. So for example, all of the leathers used for making gloves are chrome tanned. How do you make a difference, or how do you know whether your leather was chrome tanned or vegetable tanned, or tanned by using vegetable tanning? Honestly, it can be quite difficult sometimes, because it is not very obvious from the way that leather looks. More than 90% of the leathers out there these days are tanned using chrome tan leather, are tanned using chrome tanning. Why is chrome a bit of a concern these days? Chrome is a heavy metal, and as such it's quite difficult to dispose of in any of its formats. The chrome which is used for leather tanning is called the chromium-3. However, there is also another version of chromium out there which is called chromium-6. Chromium-6 is something that you definitely don't want anywhere near you, around you, in you, on you, because it's highly toxic. What happens sometimes in nature is that the chromium-3 can transform into chromium-6 in presence of water and oxygen. That's why, storing of this waste can be problematic if not done properly. Now let's talk about what is out there if you don't want to use animal leather. Let's talk about leather alternatives. The most commonly known leather alternatives out there, which we have had available for decades, are the fox leathers. These are polymer-based materials based on a textile backing and a layer of usually petroleum-based polymers such as polyurethane or polyvinyl chlorides. During the first half of 20th century, we've had some other interesting alternatives out there. For example, during the Second World War, there was a material manufactured in Germany called the Pressstoff, which was made from compressed layers of pulp, binded together by some kind of resin. However, it lacked necessary flexibility and flexing endurance, which limited its use, and that is why you cannot really see a lot of Pressstoff out there these days. Another kind of historical alternative to leather was called Rexine. Yes, it is the Rexine as we know it here in India, the Rexine that's used on all the train seats in all the trains probably out there in India. Originally, it was manufactured by a company in United Kingdom, and it was based on nitrocellulose, camphor oil, alcohol, and pigments, and it was embossed to look like leather. These days, in India, all the fox leathers are actually colloquially called Rexine. Apart from that, of course, we've had cork leather for a long time, which is made of compressed layers of bark of a cork tree adhered to textile backing. Apart from that, people have been using things like waxed canvas or linseed oil infused textiles as alternatives to leather very often too. Now let's talk about what is out there for us except of polyurethane or PVC based leathers. Sadly, many of the materials out there which are branded as alternatives to leather or vegan leathers still do contain polyurethane in their formulation, but the manufacturers and brands are very clever at disguising this fact, although it is really this kind of chemistry that the materials are actually relying on. What do the alternatives to leather try to do as materials? Obviously, they try to mimic the leather as closely as possible, and that is with their aesthetics, mechanical properties, and by the construction very often too. They try to do that while keeping the environmental impact of their manufacturing process to the minimum, and very often they also choose ingredients and that are not derived from the animals that would give them an additional benefit of being branded as vegan materials. And most of them try to mimic the actual animal leather construction as well. And we will talk about that in the following section. So we already said that an animal leather is actually a sort of a non-woven mat of fibers that are cross-linked together. And in the case of animal skin, the collagen and elastin fibers are distributed in different densities throughout the section of the skin. So at the bottom, they will be more loosely attached together and more widely spaced. And in the upper parts, they will be more densely distributed. And this is all very important because that's exactly what gives animal leather its wonderful tactile properties, softness, and whatever we are used to when we think of leather. In case of alternatives to leather, we also can talk about the fibril or fiber part and the part of the construction of the material that binds the fibers together. So when it comes to compounds of alternatives to leather, they can be either based on petroleum-based polymers. Very often they are based on cellulose, or they are based on some form of chitin or chitosan. However, usually these alternatives to leather are composites by nature, which means that they will use a combination of these materials together in order to achieve the final material composition. And apart from these basic building components, there will be often different kinds of additives which are also important in material construction, because these are the things that make them look, feel, and perform in certain ways. And these may be different kinds of solvents, for example, very important in PU-based fox leathers, because PU needs to be liquefied or made into a liquid in order to be molded over the release paper. And you can have different kinds of solvents. Then we have things such as cross-linking agents. Cross-linking agents are there in most of the materials, whether it's animal leathers or fox leathers, alternatives to leathers, and they are there to help us create materials that are more densely interconnected. They help us bridge the bonds between the molecules that the material compounds are made of. As a result, we then get materials with better tensile strength or better abrasion resistance, etc. Apart from cross-linkers, another important part of the materials are plasticizers, because most of these materials in nature would not necessarily be soft and pliable. In order to make them soft and pliable, we need plasticizers, which act as kind of spacers between the bonds between molecules, which help the fibers and components in the material move freely, and this creates flexibility in the material. Then we have the already mentioned binders, which help to put all the components together, glue them together. Very often when we talk about alternatives to leather, they will have a construction based on textile backing and the front layer of the material. And in order to attach the textile backing to the front layer of the material, you need some kind of adhesive to bring them together. And another super important part of construction of materials are coatings. Coatings are there to improve the surface finishes, to improve the aesthetics of the material, but also to bring out or improve certain mechanical properties such as abrasion resistance, such as moisture resistance, etc. And all of these components of your materials can be made from different ingredients, and these can be synthetic, they can be natural, they can be a mix of both, and obviously it's part of the companies or material manufacturers' IP, so not all of them will be openly disclosed. However, it's equally important to actually know what's being used to the maximum extent in your material, because it largely determines whether the company claims that the material is fully natural or not. So, for example, when we have a material which claims to be made of, let's say, jackfruit, for example, you would naturally, by association, imagine a material which is entirely made from this kind of fruit. But you have to think differently, because if we would be just talking about jackfruit leather made 100% from jackfruit, we would be ending up with this kind of culinary sheet of fruit leather that is edible. In the world of materials, this would not be very usable, because it's not a preserved material, so it would be easily attacked by all sorts of living organisms, ranging from molds, yeast, bacteria, ants, etc. And it would be very far from having the properties of an actual leather-like material. In order to make it a material which we can use as an alternative to leather, we need to add quite a bit of, other components out there. So the jackfruit part usually would act as a type of a biomass, and this biomass in material construction acts as a so-called filler, which is what creates the volume, the body of the material. But there we need to use an additional thing. First of all, we need to use usually some kind of binder to create strong material. And this binder can be made from different things. It can be made from polyurethane. It can be made from some kind of bioplastics, such as PLA. It can be made from chitosan. It can be made from some cellulose derivatives or microbial cellulose. Apart from that, we would need to probably use some kind of cross-linker to strengthen the bonds, to densify our materials. We would need to use a plasticizer to make our jackfruit leather softer. We would need to use a textile backing, because our jackfruit leather would not be very strong on its own. It would be very easy to tear it. And so this naturally means you would need to use an adhesive and some kind of textile at the back. So our jackfruit leather then ends up being a lot more than just the jackfruit, and it's important to know that, and it's important to know what are the other components that create the material that we are working with. Now, when we talked about our, let's say, different kinds of fruit leather or fox leather, these would be material construction and manufacturing process that would be assembled online, which naturally means they're assembled by humans. But apart from that, we also have a group of materials out there which are emerging these days, which are called bioassembled. And this means that they are actually manufactured by something else than human, and they can be made or bioassembled by fungi, in which case we would have mycelium-based mats. Or they can be made by different kinds of bacteria. For example, just like we in Malai, at Malai work with bacterial cellulose, which is assembled by acetobacter. And this is really exciting, because by creating bioassembled materials, you can cut down some of the manufacturing processes that would be necessary otherwise with creating materials by coagulation process or by non-woven mat creation process. Because while you are growing your bioassembled material, you can grow in a piece of material into it. For example, a piece of textile, which naturally cuts away and cuts down the use of adhesive. You can also load it with different kinds of active compounds to help it be more resistant to, bacteria or fungi, or to slow down its biodegradation process. Of course, you would still need some additives to transform this bioassembled material into an actual piece of leather-like material. You would still need, let's say, plasticizers and cross-linkers in order to improve some of the mechanical properties. In some cases, you would still need different, coating treatments, etc. So that is also there. And while searching or trying to understand the material choice out there, you should definitely try to find out to the maximum extent what is it that actually constitutes your material, how is the material made, and what impact does the manufacturing process and the ingredients have on the biodegradability or compostability of the material. Because while a lot of materials out there claim that they are biodegradable, many of them don't actually mention in what time frame would they biodegrade and under what conditions. And that is very important to understand, because in real life conditions, we expose our materials to different climates, to different environmental conditions, different soil environments, and these all have an impact on materials biodegradability. So try to find out to the maximum extent what your material actually is. Don't go just by the fact that the material says that it's vegan and it's biodegradable. Try to find out more details, because they really are important. If you'd like to learn a little bit more about some of the vocabulary that we talked about, you can find a link to a folder on a Google Drive below, and see the document we created with some of the most important words that we mentioned today, and also some of the links to interesting videos where you can find out more. So that will be it from me for today. I think we covered really just the basics of the alternatives to leather, but please do let me know in your comments or in messages if there is anything more you'd like me to cover from this area, and we'll make sure to prepare an episode on that for you. Next time we'll be talking to an esteemed guest. I'll be talking to my dear friend and peer Vlasta Kubusova, who is also from Slovakia and who's been heading Crafting Plastics Studio. They are an emerging material design studio based in Bratislava in Slovakia. They've been working with different kinds of bioplastics out there for over, I think, a decade now as well. And we'll talk about not only bioplastics, but also what is it, how does it feel, and what was the journey of setting up a material design practice for them. So stay tuned. I'll be looking forward to seeing you again. Thank you for your attention. Bye-bye.